Hello, everybody, and welcome to this webinar, which will be about sports marker set and its integration in QTM, and also how to use it in the PAF modules. So today, I won't be alone. So to start with, I'm Vincent. I'm a research engineer at Qualisys. And I've been responsible for the skeleton solver work since I came here in 2015. Like I just said, today I will be with like two of my colleagues, Sten. Maybe Sten, you can come into the, yeah, here. So Sten is like a colleague also, but today will be like the subject for our demo, which will be about cycling. You can see already the bike in the background. And I will be also with Irvin, who is like working with support. And today we'll be responsible for the chat. So every time if you have a question, you just write your question in the chat if you have any comments, and Irvin will be here to answer those questions. And at the end of this webinar, we will also take some time to answer the questions verbally, if we can. And if we need to have like more detailed like answers, we will respond like via emails if it's necessary. Okay, so let's start about the sports marker set. So I will start with a few slides, and I will jump into QTM from time to time, and we will have a live demo at the end. So the sports marker set, and in general, what we want to do with motion capture and especially when we deal with humans, it's to go from markers to either like animation or analysis. So animation, like you can see here for in Motion Builder, for instance, if you want to have an avatar. And also for analysis, if you want to do some analysis about the body segments of a person. So to have like to get these results from the 2D positions, we need to have like a good workflow. And to have this good workflow, what we need is to have a skeleton pose. So, and to have a skeleton pose, it means that we need to have like a skeleton solver and a way to model the skeleton. So this skeleton solving and skeleton modeling are going hand in hand. And the definition is quite simple and quite obvious. So the skeleton modeling is a definition of the skeleton model, such as the joint position and the segment kernel system. And in Qualisys, and sometimes also not only at Qualisys, but what we call skeleton model is also called like marker set. So each marker set that we have at Qualisys is like a different definition of a skeleton. So it means approximately the same thing. And secondly, we have the skeleton solving, and what the skeleton solving is doing is the process of fitting the skeleton model that we just defined before to a cloud of points. So the idea is to fit the skeleton, as you can see in the middle, to the cloud of points that we get in QTM. So a bit of like timeline regarding the skeleton solver at Qualisys. So in 2015, we started to with like our skeleton solver, but it was inside our PAF module for sports, and it was very specific to running, and it was very offline. So we got some feedback. We gathered a lot of feedback, and we decided in 2019 to get like to build or to implement a skeleton solver with one skeleton model, which is the animation marker set. So in this case, we have something quite a bit more generic. It's inside QTM. It can be used in real time and offline, but unfortunately, since it was since our focus was for animation customer, we had like defined an animation marker set at that time, which was not using biomechanical like definitions. But this year, a few months ago, or 1 month ago, I would say, we launched like a new marker set that is supported inside QTM. And Once again, like the animation one, this marker set works in real time and offline. And on top of that, it's using biomechanical definitions for the joints in the current systems. And on top of that, which is very useful, you will see it later, it's compatible with our PAF modules, because our PAF modules are already using the sports marker set. So let's focus a bit about this last part. What about the QTM workflow when you use like our marker set or our skeleton models, and especially the sports marker set? So the sports marker set and the animation marker set, there is not so much difference. The only difference that you will see, it's that the animation marker set on the left side here uses the T-pose to create the skeleton, while the sports marker set uses like a more natural pose that we call the A pose. And it's like already what we use in our sports PAF modules. So the way to create a skeleton, maybe I can show it to you now in QTM. So if I look at the file, so I've recorded a few files yesterday. So I'm jumping into the session here, and I have like one file that we collected yesterday where we have stem. So we have like all the markers that are labeled. And as you can see, for the sports marker set, we don't need any T-pose. We just need an A pose, a natural pose. And what you can do, you can just create a skeleton here. So you click on this button, Calibrate Skeleton, and you have your skeleton. So that's the first step. And then what you do, you can save the file, and you can go to a cycling one, open it, and instead of recreating a skeleton, what you have to do is to use the skeleton that you have defined during the static on this specific cycling motion. So what you can do now is go to Process, and you have to check the box Solve Skeleton. And as you can see now, we have a skeleton called Q, which is the skeleton that we just created. And you can click on OK. And it will solve the skeleton using the definition that was created using the static file. So you do that for all the motions that you want to record and that you have recorded, and then you can use that skeleton as you wish. So if I'm going back to the presentation now, so that was the QTM workflow. But now what's also interesting for you probably is to know how to use it in combination with the PAF modules. Because like I said, the PAF modules now, they use the same sports marker set. So let's look at how right now it is working with the sports marker set with the PAF module. So you have QTM where you record the data. You press the analysis button, and Visual 3D will define the skeleton, run the analysis for this specific sports like baseball or running or cycling or golf, and it will export the data in our like report center, so you can have a web report. So what is very important here, and this is what I'm trying to summarize, it's like our PAF modules, they use the sports marker set where the skeleton is calculated from Visual 3D. This Visual 3D skeleton is used for the analysis and to get a report. And now, since 2020 and this release, with QTM, we can create a skeleton also, like you just saw before, and we can use it in real time, also in file mode, but we can use it in real time for either plotting in real time some skeleton data, if you're interested into that, or also if you want to, you can use it to stream to third-party softwares. So if I summarize again, this last part, QTM uses the same sports marker set, so the same marker location, but this time the skeleton is created from QTM, which makes it possible to stream to this skeleton into third-party software. And also, if you want, you can plot the skeleton data in real time or in file mode, and you can also stream the data, the skeleton data, into third-party software such as Unity, for instance. Talking about the marker placement or the marker location, I mean, as you saw, regarding the timeline, we started with like the running. So 90% of this marker set is based on the one that we use for running. But since we wanted to have it, that we can also, use it for different movements, such as baseball, golf, or cycling, we decided to customize it a bit. So to be sure that the tracking would be good enough for other sports than running. So we added a few markers, 2 additional markers on the pelvis and 1 additional marker on each arm. Also, we added a static marker on the internal side of the knee. So this medial knee marker is only necessary or mandatory for the static, and it can be removed during the dynamic movement if you want to. One thing also to notice and to talk about, it's that you can see yellow markers. These yellow markers means that the markers can be moved on the segment, so they don't have to be precisely put on the exact location as you see on the pictures. So it can be useful sometimes if you face some tracking issues. You can move a bit the markers on the side of the thigh instead, for instance, so instead of having them on the front. So as soon as the markers are staying on the same segment, it's totally fine. Going back to QTM, this marker set or this marker guide, they of course can be found if you have a PAF module. They can be found in your PAF module the usual way when you click on Show Guide. But if you don't use the PAF module, that's you can still have access to this marker set or this marker guide. You just have to go to Skeleton. And you will see that now you have 2 possibilities. You have the animation marker set guide, but you have also now the sports marker set guide. And as soon as you click on it, you will see a few pictures. It's a PDF which contains the marker placement for the markers. And you can see, like I said, which markers can be moved. And the exact location to help you to place them correctly. Regarding the skeleton itself, so there is no big there is no big difference. There is of course differences between the animation and the sports marker set, but they are similar in a way that the marker names are the same between the animation and the sports one, and also the number of segments is the same. The thing that differs, of course, is what I call here the segment coordinate system. So these axes that you attach to each segment, they are different, and also the joint position are different between those 2 marker sets to follow, of course, more biomechanical definition. A few details that you might want to know also, the neck segment is locked since we don't have so many markers on the back. So we had to lock a few segments that were here. The shoulder, which is here to represent the clavicle and the scapula, they can move up and down, and they can move forward and backwards. And all the thorax is moving through the spine segment, which is the first segment of the whole trunk, and the other one, spine 1 and spine 2, they are locked. And the same thing is happening for the forefoot, that we call toe base in our case. So the forefoot is also locked because we don't have any markers on that part, so we are locking it. Like I said before, we wanted to be sure that this marker set would work not only on running but on many applications. So we did a lot of internal testing and internal validation using our different sports module. And we, as you can see, we try to validate it with what we have. So the baseball, cycling, golf, and running applications. One very nice feature also that we have since this release with the sports marker set, it's that you can use real-time skeleton plotting in QTM, meaning that if you have a skeleton, you can plot the joint angles of a segment and see the output directly in real time in QTM. I will show it later during the live demo, just in a few minutes. Also, there is a new type of export that is supported because we know that with the sports marker sets, maybe a lot of people wants to work with like MATLAB. So we decided to support the math extension. So we are able now to export skeleton into math files. And of course, all the skeletons can still be exported in FBX and TSV. Regarding the streaming, on the left side of the screen, we can stream data, both marker sets, to Motion Builder, Maya, Unity, Unreal, iClone, and you can use the Python plugin also. So most of these plugins, they are available on our GitHub account on Qualisys. So if you go to GitHub /Qualisys, you can have access to all the plugins and start to play with the skeleton data if you want to. Yes. So now it's time for a demo. We were going to show you the cycling module with the sports marker set. So from recording to web report. And I'm going to show you like a small example about QTM, the sports marker set, and the real-time feedback. Okay, perfect. So I'm going to switch to the session I've created. So I've created a session, and now we can go live maybe. So I'm going live. So I'm going to remove the skeleton I created before to start from scratch. As you can see also, we have like a mesh. So we have stand here and we have a bike. Yeah, you see? So we now in QTM, we have the possibility to have like a mesh inside. So this one is a static mesh, and maybe it will be probably the topic of another webinar, but I can show you quickly how do you do that. So now in QTM, you have this static mesh object, and you can add a mesh, and you can also, if I double click on it, you can also change, of course, its position in the world space and rotating it. So this is what I did. As you can see, I played a bit with like the offsets, so I can put the bike at the correct location. You can also use a different scaling and also a different opacity if you want to. So if you want to have that one, if you want to use like meshes, you have to do it this way. So now in your project, when you will create a project, you will have a meshes folder. So what you have to do is to put like all your objet file in that one with all the textures, and QTM will recognize it automatically. Okay. So going back to our like session, the PAF one, we have I've recorded a file. The first one is just with the bike. So if I open it, I was having like a bike session, like a bike static file trial, sorry, where I put some markers on the bike. So that was the first one. And now the second one is to capture like a static one. So I'm gonna ask Stan to stand still. Perfect. And I'm gonna capture. Perfect. So as you can see, we have the aim is automatically applied to the data. So right now we don't have any skeleton. We just have like a PAF module, of course. We just have like the markers, sorry. And now what I can tell Stan, it's probably to I can jump into real time again. And now if I want to have a skeleton, I can do it now if I want. So it's just standing still, or I can use a static file and I can press on calibrate skeleton. And as you can see, immediately now we are in real time and I have a skeleton inside QTM. So as you can see, it's very interesting for like potential use, because you can have at the same time your PAF module, and you can at the same time have the PAF module with a skeleton inside QTM, meaning that you can use it for real-time feedback, for instance. And this is what I'm gonna show now. So what we're gonna do now, we're gonna show the whole workflow. Let's say that you want to capture cycling trial in your PAF project. So I'm gonna ask Stan to jump on the bike. So now Stan is on the bike. Yeah, so he's gonna pedal for a while, and I'm gonna capture like one trial, let's say. So I'm capturing now. Perfect. So during in the cycling path module, we have to set the watts. So this is what I'm trying to do. So it was 100. And then what we can do with that, it's like you can, of course, like create a report. So this is usually what we do. I can see also that the left crank was not having so many markers, so I can help that, maybe. Yeah, so the left crank is having like some issues a tiny bit to label it, but you see it was just 3 clicks. So I can look now and see that I have like almost everything is at 100%. So I can save this file, and I think I can export it. So this is the workflow that you can use for the PAF modules, and we are gonna wait a few seconds. Visual 2D is gonna start processing, and it should create like a web report at the end. And after that, what we're gonna show, we're gonna show what we can do with the QTM solver, the QTM skeleton. So just waiting a tiny bit. So now Visual 3D has been processing and it's done. And as you can see now, I have like a web report that I can claim, that I can open. And if you are a user, for instance, you can see like all the data that you want. And then if you want to go further than that, if you want to do some adjustment of on the bike, for instance, and do some tests, now with the skeleton solver, you can do that since it's compatible. So now if I'm turning live, and if I saw a few things that I would like to change, I have Stan here on the bike. And for instance, if I want to look at, like you saw before, I can plot the data of the skeleton. So I just open the data info window, click on skeleton data, and after that, yeah, as you can see, I have the skeleton data, and I have like all the segments. So if I ask Stan to stand still, maybe for a while, thank you. So I can have Stan stand still, yeah, don't move. So I'm gonna try to put, for instance, to display the thigh relative to the pelvis, which is a joint angle. So I can do that in real time. And I want to display, for instance, the flexion extension, which is the roll in our case. So I can plot that, and be careful to have like the local coordinates checked. So local coordinates means like it's a joint angle, it's a relative angle with the parent. If you don't have that, you will have the segment relative to the global coordinate system. So I click here, and as you can see, Stan is standing still now, but if he starts to pedal a tiny bit, yeah. So now you can see in real time, the flexion extension of the tie for stem. And if you want to do, like I said, adjustment to the bike, some changing in the saddle height, for instance, you can see directly the effect of it on the tie, on the joint angles for the flexion extension, for instance, of the tie segment. And what we can do also is we can go a bit further than that. And if I'm going now to like the Unity project that I had, that I created, I can, like I said, I mean, you can, of course, if I go back here, like I said, on this GitHub account, you can download like the Unity package that we have, and you can work with it, for instance, to have like real-time feedback. So we made a small example where we're gonna show you now, where we have the cycling one, and we're gonna show you a bit. So I just need to find the window for Unity. Perfect. So we modified a bit the Unity script that we have on the GitHub project. And now, Stan, you can pedal. Yeah. So in this Unity project that we made, we use the one that you can download on GitHub. And we made some modification to have real-time feedback using the skeleton and the sports marker sets. And the example that we took right now, it's using like the trunk position and saying that, as you can see, it's turning from red to green, because when you are like, you should have like a correct position of the bike. And if you have a position, for instance, let's say that is like below, or I mean, your trunk position is like below 35 degrees, for instance, or above 50 degrees, then it will turn red and it's a bad position. So you can have this kind of like real-time feedback if you want to, and it's quite easy nowadays to implement it if you have some basic knowledge about Unity, to create this kind of feedback using the skeleton data, because the skeleton data are already available in our package. So this example, of course, is not available, but on our GitHub project, but the basis to start with is, of course, available, and this is what we use to make this small example. So that was like the subject that I wanted to talk about today. So I hope that you enjoyed it, that you have a good time. I would like to thank you all for listening and watching it. And I would like to thank, of course, my colleagues who were there. Next week webinar will be about the trajectory editor. And now I'm gonna take some time to answer to some questions if needed. Thank you very much again for your times, everyone. Yeah. Okay. So I got a questions. We got a questions about soft tissue artifact. Apparently. So. Just a second. So. If I look at the question, so what about soft tissue artifact in this on this model? Pelvic tilts and thigh rotation is really sensitive if we lost markers. Is it possible to get the marker? Yes, so pelvic tilts and thigh rotation is very sensitive in running, for example. I agree. So the idea about using a model and soft tissue artifact, it's like the biomechanical model we use is like based on a rigid model, meaning that the model itself, or the skeleton model, they have a strict position of the markers in the segments. So it means that if the marker on your subject moves a lot, the skeleton solver, because it has these constraints, it will be less influenced by the soft tissue artifact. Also, what you can do, and that's also something I didn't talk about, but you can, of course, also change the weight on some markers. So if you think that some markers, they will be influenced a lot because there is a lot of soft tissue artifact or soft tissues underneath the marker, you can change the weight of this marker. I didn't talk about that today, but you can do that in QTM. If you export the skeleton, and if you export the skeleton, you can change the marker weights if you want. And the default marker weight is 1, and if you decrease the marker weight to say something close to 0, it means that the skeleton solver will almost ignore it. And if you do the opposite, if you put a value that is above 1, then it means that the skeleton solver will trust this marker even more. So that's the two things that I could think about regarding the soft tissue artifacts. Yeah. Okay. Yeah. Yeah. Mm-hmm. Yeah. Yeah. So yeah. Oh yeah, there are a lot of questions. Yeah. So a lot of questions. Yeah. 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 So I'm looking at the questions right now. So is there a baseball version of that skeleton model on GitHub? So from Jake. So Jake, there is no, the skeleton model can be used inside QTM. And if you have the PAF module for baseball, you can use it both, as I just, the way I was showing it for cycling, this is possible. On the GitHub, what we store, it's not the skeleton. We don't have like a specific thing about skeletons. We store like our plugins, for instance. So if you want to stream something about baseball to Unity, for instance, you can just download the Unity plugin and use it. Is it necessary to define bones to use the skeleton? No. The only thing that matters is to use the sports marker set. So if you use the sports marker set, Cathy, it's fine. You don't have to define anything on your own. How does the kinematic model compute glenohumeral joint motion angles? So on top of my head, it's a bit difficult to answer this question, but I can try to think about it. Yes, so the glenohumeral joint, the joint itself is calculated using like regression equations that we found in the literature, and we define the coordinate system based on the ISB recommendations, and that it's an article from 2001 or something like that, I think, Mark. And we use that to calculate, like I said, to assign the coordinate system to the arm. And then to calculate the joint angles, you can do that on your own if you want, because if you export the result, for instance, in MATLAB, or if you want to stream it to Unity, you can do the relative motions of the joint of the arm. So if you want to take the arm relative to the shoulder segment or relative to the thorax, for instance, if you prefer, you can do that on your own. And right now, what you saw in QTM about the joint angles that we were able to display, it's the arm relative to the shoulder bone or the clavicle. This is how we do it. Is it necessary to have the PAF module to use the sports marker set and the skeleton solver? No. Taneke is not mandatory. If you want to use the sports marker set inside QTM, then it's coming directly with QTM. You don't have to do anything else or to purchase any PAF module. So I hope, so yes, it can be used independently. So the next question, do you plan to have the same concept for the clinical gate? That's a good question. The only problem, or it's not a problem, it's like this marker set that we have right now, that's why we call it sports marker set, Alberto. It's because for gates, people have different guidelines to create the marker set. So if right now it's not going to work, so to speak, because people are like looking for another type of marker set for gate. So it means that we will need to have like another like gate. We need to have like a gate marker set in QTM to be able to do the same thing. But of course, we can dream about it, and maybe in the future it will be possible. Eric Hanley, does the sports marker set allow for full wrist data in the golf module? Oh, regarding the golf module, so in the golf module, I have to look at that. I will have to answer. I will have to look at that with my colleagues, because I can't remember on the top of my head which movement or which angles do we have already in our golf module. But if I remember correctly, I think we are displaying the we have already some graphs in our report, and also in the Visual 3D report that we use for golf module that includes wrist motion data. But I can confirm it to you personally if you want. Yes. We have another question. For non-cyclic movement, can center of mass be calculated easily from this? From Shiam. Yes, it can be, of course. So you can calculate the center of mass if you export the QTM files into MATLAB, for instance, to process them. Unfortunately, in live, it's not possible to have like the center of mass of the skeleton. So if you export the data in QTM, you can play with the data as you wish, and you can use anthropometric tables to assign like the mass and the center of mass for each segment, and at the end you can calculate the global center of mass of the whole body. That's something that you can do quite easily in MATLAB, of course. Have you tried this setup with lighting challenges like outside? I mean, we've been doing some baseball outside, if I remember, Ivan. So, and it went okay. So you just need to have the right filters for the cameras, and it should be fine. If we only process the data with Visual 3D, there is no added values to compute the skeleton solver, right? So from Felix. So the idea with Visual 3D, when you use Visual 3D and the module, of course, if you're already satisfied with what Visual 3D gives you offline, then that's okay. But if you want to have like real-time feedback, for instance, you can use directly the skeleton from QTM, since it's defined the same way as the Visual 3D one. And the next question from Felix was, all PAF deals correctly with the added suffix on the markers names? Yes. The Q underscore, which is like the default one that shouldn't be changed for the name of the skeleton. If people are using this one, the PAF module will work perfectly fine. My God, that's a lot of questions left. I can see what I can do, but let's take 5 more minutes maybe. I have Andrea, a question about from Andrea. Is this sports marker set more sensible to changes in acceleration and velocity. I am experiencing some marker drift after perturbation-based trails which occur at high velocity. I don't think so. I mean, it's the skeleton should be the same if you capture it with fast or slow movements. As soon as, of course, you have like a good sampling frequency when you capture the data. So yeah, as soon as you have like a good sampling frequency, it should be fine. Questions from Renato from Brazil. So congratulations for the innovation. So thank you very much. Will it be possible to add a tracking cluster to the skeleton in some segments to optimize data quality for research? Trying to think about what you mean by that, Renato. Would it be possible to add a tracking cluster to the skeleton? So what you can do, actually, if I know what you mean, you can have extra markers. So if you think that you will need extra markers to improve the tracking because you have some challenging conditions, so it's possible. So the only thing that you have to do, Renato, is you put the markers, and you have to, in the documentation, when you open the marker set guide, or if you go to documentation on QTM, it will tell you how you should, what would be the name, what's the procedure to add these extra markers so they can be included in the skeleton and the tracking of the segments. But yeah, it's definitely possible to add more markers for each segment. And I agree with you, it will help a lot of the tracking if you need it, because since you will have more marker per segment, you will have a lot of redundancy. So you will have something a bit better in terms of tracking, especially in challenging conditions. Any way of running, Chris, any way of running custom marker names modifying the skeleton solver? So this question is yes and no. So from Chris, there is a way to add custom marker names, definitely. This, if you go to YouTube, we have a YouTube channel where we mention how to modify the custom names. So if you go to YouTube and look at the Qualisys channel, we have a playlist for skeleton solver, and there is one video regarding that topic. So modifying the marker names is definitely possible. Modifying the skeleton solver itself, that's unfortunately not possible yet, meaning that you cannot modify the definition. You can add weights, like I said before, to the markers if you want to have different weights. You can also play with the joint constraints, like meaning like you can play with like the boundaries. So that's the thing that you can do. And once again, there is like there is a tutorial on YouTube that show you how to do that. And it's the same, actually, it's the same video than the one for modifying marker names, because the one for marker names shows how to export the skeleton. So if you can export the skeleton, you will have an XML file. In this XML file, you can modify, like I said, the boundaries for the joint constraints if you want to, and the marker weights. So I think it's still a lot of questions left, unfortunately. So what I will do, we promise that we will answer all the questions. So what I will do now, I will close this webinar. At least I will not answer verbally, but what I will do for all of you who wrote those questions, me and Irvin, we're gonna sit down and we're gonna try to answer to all of them as much as we can, if it's possible. Yes. So thank you again to everyone. Stay safe, and thank you again for being here and listening and watching this tutorial. Thank you very much.